Hello everyone and welcome to lecture of our data structure algorithm series. I am Dr. Mangesh Joshi from Department of Mechanical Engineering. In this session, we will be learning about quicksort, one of the fastest and most widely used sorting algorithm. It is known for its efficient performance and elegant use of the divide and conquer approach. Without wasting any time, let's begin with the quicksort. So quicksort, as I already told you, is a divide and conquer algorithm that sorts by selecting a pivot element and partitioning the array around it. It basically works by selecting special element, which we are calling it as pivot, right? And then partitioning the array around this pivot. Then all the elements smaller than the pivot are moved to the left side of the pivot and all the greater elements to the right. This is the key idea behind quicksort. Then we apply the same logic recursively to the left and right parts. In this way, it organizes or sorts data in ascending order. Like, for example, you're organizing a bookshelf by picking one book. Suppose you're having some bookshelf like this. Then you are picking one book and placing others before or after it based on the size of that book. So basically what you are doing, you are picking one book and then arrange the others based on whether they are smaller in size or larger in size. Over the time, whole shelf will arranged in organized manner. So let us understand step by step how quicksort works. So first step in quicksort is choose a pivot element. Then partition the array into two parts. Suppose you have some array like this. Right? Suppose you're having such array. Then we will select one pivot. We are having one numerical example. So suppose we select this as pivot. So element less than the pivot, and then we will identify. So this partitioning is basically done in two parts, right? So elements less than the pivot and elements greater than the pivot are identified and recursively apply the same process to each partition, right? So this element is greater than 7, so it will be moved to the right. This element is less than 7, so this will move to the left. That is the basic logic. So let us break down how quicksort works step by step. So let us see that this is a unsorted array 11, 9, 12, 7, 3. And suppose we are choosing the last element as the pivot, for example, right? So which is 3. Now we will move values less than 3 to the left and greater than 3 on the right. So all you can see in this array that all the values are greater than 3. So swap pivot 3 with the first element. So all the values are stored here on this side. So this 3 will go here, 11 will go here, right? So now pivot 3 is in correct position. Now focus on the remaining part of the unsorted array. because 3 is already sort. So remaining part is 9, 12, 7, 11. So suppose we are selecting 11 as pivot, move values less than 11 to the left. So 9 is already on the left side, 7 is already on the left side, but this 12 is greater than 11. So this will go over here, right? So swap 7 and 12 first, which becomes 397. Then swap 11 and 12, it becomes 397, 11, 12. Now 11 is in correct position, right? In this way now 11 is now in correct position. Now sub array 9 and 7. Choose 7 as pivot now, remaining part. This is already in the correct position. This is already in the correct position. So only remaining is 9 and 7. So you are selecting 7 as this. So again swap 9 and 7 as 9 is greater than 7. So 9 will go on the right side of 7 and you will ultimately get 3, 7, 9, 11, 12. Finally sorted array. So to implement this quick sort in a programming language, we need array containing those elements to be sorted, a partition function to place the pivot at correct position, and recursive calls to sort the left and right subarrays. So basically the strength of this quicksort lies in the partitioning process. A well-chosen pivot leads to smaller recursive steps and better performance. So you know that selection of this pivot is very, very important to have smaller recursive steps and better performance. So the performance is basically dependent on how you select the pivot. So this is quick sort in C language. First function to swap two elements using pointers. So pointers are used as whatever the swapping is done, it will reflect to the address of that variable. That's why pointers are used. Then function to partition the array is given. So int partition, int array, int low, int high. So choose the first element as the pivot, for example. So here you can see ARR of low. So low might be 0 and high is nothing but the last n minus 1, right? So this is given program I scans from the beginning, j scans from the end, right? So all the logic is given over here and what each function does is also given. Just go with this code and understand what it basically doing. Whatever logic we have used over here, it is written over here. Each loop performs some function which is assigned to it. Then this is quick sort algorithm. This is code for quick sort function. This PI is basically the index of the pivot element. Partition is the function name which you already created over here. This is the calling of quicksort function. It is a recursive call. The name of the function is quicksort only. and you're calling the same function within itself, right? So this is called as a recursive call to sort left subarray, to sort right subarray, and finally the main function. So firstly, this is called quicksort. This array is passed through this. Low is 0, high is n minus 1, as I've already told you. It will start low value is 0 and finally n minus 1 is the high value. That is basically the bounds of the array are representing low and high means, right? Let us come to pros and cons. So very fast in practice, average time is n log n only. Work in place with small memory overhead. So it does not require, or it requires negligible additional memory. Cons, worst case time complexity is n square. This happens when the pivot selection is poor. For example, when the array is already sorted, if you provide input that the array which is already sorted, then it is time complexity is n square. Again, it is not stable. Equal elements may not keep their original relative order. If the two values are same, then original order may not be the same, right? And it can lead to deep recursion, which might cause stack overflow if not optimized properly. Still, with proper pivot strategy and tail recursion optimization, quicksort is very powerful algorithm. Coming to the conclusion of this video lecture. So we have looked at how algorithm works, how to implement it, and its practical strengths as well as weaknesses. In upcoming lectures, we will explore more sorting techniques like merge sort, heap sort, etc. And we will start comparing them in real world scenarios. So thank you for joining in, and as always, feel free to reach out if you have any questions. See you in the next lecture. Have a nice day.